In this question, a block of mass m containing a net positive charge q is placed on a smooth horizontal table which terminates in a vertical wall as shown in the figure here. The distance of the block from the wall is small d. A horizontal electric field capital A is acting towards right is switched on. Assume its elastic collision. We have to find the time period of the resulting oscillatory motion and also check whether it is a SHM or not. So in this figure, we have a charged body whose mass is m and it is present under the electric field E, and the distance between the wall is small d. So we have to find the time period of the resulting oscillatory motion. So we know that due to the presence of electric field, there must be the electric force acting on it. So F is equal to Q into E, and F is equal to m into A based on Newton's second law. So if we equate these two relations, we can say that m into A is equal to Q into E. So A is equal to QE by m. We got the acceleration. Now we have to find how much time it will take to reach from point A to the point B. So we can say that S is equal to ut plus half at square. Here u is equal to 0 because it's just started from the rest, and s is nothing but a small d. This term becomes 0. So d is equal to half into a into t square. So t square is nothing but 2d by a. So if we substitute the a value that we previously got it here in this relation, so we can say that t square is equal to 2d by QE into m. So t is equal to 2d by m divided by QE under root. So this is the time period from A to B. Now body has to come back to the initial position. So what is the time between B to A? So according to the question, here you see the body is following elastic collision. Elastic collision means this wall is not going to move anywhere. This will remain at rest. So the initial velocity of wall is equal to 0. It means that when this body is about to hit the surface, the body will follow the same magnitude but direction will change. So due to that, speed remains the same, so time will also be same. And acceleration is already constant because q is constant, electric field is constant, and mass is also constant. So whatever the time it will take to move from A to B, same time it will take to move from B to A. So based on that, we can say that total time, which is the time period, is equal to TAB plus TBA. And here both are equal, so we can say that 2 times of the T. So we can substitute the value. T is equal to 2 into root 2 a small d m by QE is equal to 8 dm by QE. So this is the answer of this question. And in the second part, they are saying that whether the body is following the SHM or not. So for SHM, our condition is A is equal to minus omega square x. When this condition is fulfilled, then SHM is present. But we know that in this case, A is equal to constant. So no SHM. So this is the answer of this question.